This is a quadratic form given. We need to convert it to canonical form by using orthogonal transformations. Firstly, we can write it in a matrix form like this: x, y, z, x, y, z, x, x, x square, x, y by 2, x, z by 2, x, y by 2, y square, and y, z by 2, x, z by 2, y, z by 2, and z, z square. So we need to write the values. Like here it is coefficients. X square coefficient is 3. Then check for xy coefficient. It is 2, so 2 by 2 is 1. And then zx coefficient, it's also 2, then it becomes 1. Xy coefficients here, it's also 1. And y square coefficient is 3. And yz it is minus 2, so it becomes minus 1. Xz also 1. Here yz we have taken minus 1, and then z square coefficient is 3. So now this is in matrix form. Ax is equal to b. Now simply write characteristics of given matrix is A minus lambda I is equal to 0. We need to do here is add here lambda, and here lambda, like this. So 3 minus lambda plus 1, 1, 1, 3 minus lambda minus 1, 1 minus 1, 3 minus lambda. So now we have a formula here, lambda cube plus lambda square trace of matrix plus lambda minor of a11 plus minor of a22 plus minor of a33 minus det a. So lambda cube is as it is plus lambda square trace of a. So the trace of a, 3 plus 3 plus 3, it becomes 9, plus lambda minor of a11. For that we need to cancel this row and this row. 3 3 9 minus 1. So similarly minor of a22 is cancel this row and this column. 3 3 9, and 1 into 1 is 3 minus 1, plus similarly minor of a33 means cancelling this row and this column. That means 9 minus 1 plus minus det a is equal to 0. Now what is det a? Let's find out. So 3 9 minus 1 minus 1, the row column cancel. 3 plus 1, so plus 1 plus 1. Now row column cancel, minus 1 minus 3, so this is 3 8 minus 1 plus 4 plus 1 minus 4, so it is 24 minus 4 minus 4, which is 16. So this equation we substitute. So plus 9 lambda square plus this is 8 plus 8 plus 8, so it is 24 lambda minus that value 16 is equal to 0. Now we need to find eigenvalues. For that we can write it here in equation form: 1 9 24 minus 16. Okay, so let lambda is equal to 1. Let's take 1. So 1 into 1 is 1, 8. So 1 is 8. 8 minus 24, it is 16. So 1 into 16 is 16. This becomes 0. Then let's take lambda value as 4. So 0 1, 4 ones are 4, it is 4. 4 4s are 16, so this becomes 0. Now let's again take 4. Lambda is equal to 4 0 1, and 4 is 4, which is 0. So eigenvalues is equal to lambda is equal to 1 4 comma 4. Now finding eigenvectors. So case 1, let lambda is equal to 1 and the corresponding eigenvector be a minus lambda I. Here we write x1 is equal to 0. What is x1? x1 is equal to x1, x2, x3. Okay, so what we are doing here is, in this we are taking lambda value as 1, so 3 minus 1 is 2, 3 minus 1 is 2, 3 minus 1 is 2. Right here 2 1 1 1 2 minus 1 1 minus 1 2, and here it is completed. x1 is equal to x1, x2, x3 is equal to 0. From this we gain a equation to x1 x1 x2 plus x3, like this. x1 plus x2 plus x3 is equal to 0. Take this as equation 1. Here it is 1 x1 2 x2 minus 1 x3. So this becomes x1 plus 2 x2 minus x3 is equal to 0. x1 plus minus x2 plus 2 x3 is equal to 0. This is equation 2 and this is equation 3. So we do is solve equation 1 and equation 2. For solving a and b, so what is b? 1. C is also 1. B C A is 2 and then b is 1. Again into b is 2 minus 1 1 2. So x1 is equal to cross multiply minus 1 minus 2 is equal to x2 1 plus 2 is equal to x3 4 minus 1 is equal to k. x1 by minus 3 is equal to x2 by 3 is equal to x3 by 3 is equal to k. Therefore x1 is equal to minus 3, x2 is equal to 3k, x3 is equal to 3k. Eigen vectors x1 is equal to minus 3 3 3 k. So x1 is equal to, take 3 common outside, 1 minus 1 1 and 1. This is the eigenvectors. Now we need to find k's 2 eigenvectors. So lambda is equal to 4 corresponding eigenvectors b 1 minus a lambda I. x2 is equal to 0. x2 is equal to x1 x2 x3. So here we are taking lambda value as 4, so this becomes minus 1 minus 1 minus 1. So write minus 1 1 1 1 minus 1 minus 1 minus 1 minus 1 1 minus 1 minus 1. Okay, so x2 x3 is equal to 0. So we need to do row operations here. R2 tends to R2 plus R1, and so 1 minus 1 is equal to 0. R3 tends to R2 R3 plus R1, 1 minus 1 is equal to 0. We need to make this row and this row as 0. So we do that 1 1 1 0 0 0 0 0 0. Here x1 x2 x3 equal to 0. So now minus x1 plus x2 plus x3 is equal to 0. This is equation 1. So now let x3 is equal to k1 and x2 is equal to k2, x2 is equal to k2, x3 is equal to k1 in equation 1. So equation 1 becomes x minus x1 plus x2 plus k2 plus k1 is equal to 0. Send this outside. Minus x1 is equal to minus k2 minus k1. X1 minus x1 is equal to minus common we are taking plus k1. Cancel cancel. Therefore x2 is equal to x1 x2 x3. So what is x1 here? K2 plus k1, x2 k2, and what is x3? K1. So here it is k1 0 k1 plus k2 k2 0. This we can take k1 common here, so 1 0 1 plus k2 1 0 0. So x2 is equal to 1 0 1, x3 is equal to 1 1 0. So here we get x1 is equal to minus 1 1 1. So x1 is equal to minus 1 1 1. Now we find normalized model matrix n is equal to x1 x2 x3. So n is equal to, put the values minus 1 1 1 1 0 1 1 1 0. Now 1 is equal to minus 1 square by, take this row, minus 1 square plus 1 square plus 1 square. So 1 square plus 0 square plus 1 square, and then 1 square plus 1 square plus 0 square. Now in everything. So 1 square 0 square plus 1 square, so 1 square by 1 square plus 1 square plus 1 square by 0 square. So n is equal to what is remaining here, minus 1 by root 3, 1 by root 2, 1 by root 2. Here 1 by root 3, 0, 1 by root 2. So 1 by root 3, 1 by root 2, and here 0. It was 0 here, sorry. So 0. This is normalized model matrix. So this is n. So now find, so n transpose is equal to minus 1 by root 3, 1 by 3, 1 by root 3, 1 by root 2, 0, 1 by root 2, 1 by root 2, 1 by root 2, 0. Now we find diagonalized. So the formula is D is equal to n transpose A n. So simply just write eigenvalues here, 1, 4, 4, and remaining as 0, like this. So now we find canonical form is equal to y transpose dy. Y is equal to y1, y2, y3. So y transpose, so y is equal to y1, y2, y3. So y transpose is equal to y1, y2, y3. So in the formula, y1, y2, y3, d is 1, 0, 0, 0, 4, 0, 0, 0, 4, and y is y, y2, y3. So y1, so y1 square plus 4y2 square plus 4y3 square. So this is canonical form. So the rank is equal to number of non-zero rows. Here there is no row which have total 0 as values. So rank is equal to 3, nature is equal to positive, and signature is equal to 3. Therefore index is also equal to 3.